welcome to another exciting edition of mathematics being made easy. The last time we met, we looked at the quotient rule as far as differentiation with subject matter calculus is concerned. For today, we still want to continue with another differentiation, because calculus is just full of differentiations. After differentiation, then we look at other aspects of it. Then we'll move to integration and so forth and so on. So let's move on to today's lesson. For today's lesson, we'll be looking at that form of differentiation, which we call composite functions. Composite functions, into bracket, functions of a function. Functions of a function. So, assuming, or let's say that the question is given to you that y is equal to the function 2x minus 3 squared. You see, this thing is very easy to differentiate. What do? We can equally use product rule. The square is just telling us that it is repeating itself 2 times. So what we have to do is just y is equal to what? 2x minus 3, 2x minus 3. Then we can differentiate. One way of differentiating this thing is to multiply. You multiply. Y is equal to 2x multiplied by 2x. We have 4x squared minus 6x minus 6x plus 9. This is what we will get. This will give us 4x squared. This will give us negative 6x. This will also produce negative 6x. This and this will produce positive 9. Then from here we can still simplify, which is 4x squared minus 12x. This will give us minus 12x plus 9. Then we differentiate dy dx. Dy dx will be equal to 8x minus 12. This will go. The positive 9 is a constant, so it will blow. So this is what we are going to get. We can still simplify. Dy dx would be, we pull 4 out. 4 will come out. We have 2x minus 3. Because when you multiply this and this, you get 8x. You multiply this and this, you get 12x. You will see how easy it is for us to differentiate. When the exponent is something that we can manage, you can see the exponent is 2. We can manage it. Even if the exponent is 3, to a large extent, we can still manage it by expanding it. Come to think of it, when we have an exponent which is negative, or an exponent which is a fraction, what are you going to do? So, for instance, if we have a function this way, y is equal to maybe 2x minus 3 exponent negative 1 over 2, which is a half. What are you going to do with this? It will be very difficult for you to do. Without using the appropriate method, you will be fumbling. You will fumble. Or if we have something like this, y is equal to maybe 4x plus 1 to power 8. What are you going to do? Will you continue to expand? By the time you finish expanding, classes or the exam is over, you haven't achieved anything. With that, authorities decided to bring in these functions of function, or the composite function, or which we call the chain rule, to help assist. With that, we don't need to expand the number of terms that it has. We don't need to expand. What we will do is we will just equate y to be another function. We will just equate the y of this, maybe depending on the function given to you, you just equate the y to another function. With that, you are going to go. So let's take one question and see how we will solve it. It's very easy. With that, you will not fumble again. So with that, we employ the rule which we normally call the chain rule. So the chain rule helps us to solve questions that has exponents, be it negative or extremely large exponents. A function that has extremely large exponent, or a negative function, a function having a negative as an exponent, it becomes difficult. So the chain rule has come to help. Are we getting the point? So we'll take the questions to have the chain rule. You see how easy it is. With that, at the end of the lesson, I'll be teaching you some short way of solving it without going through the chain rule. But when the question asks you to use the chain rule, you can't go behind and do something else. So we'll take our first question. Our first question says that we should differentiate. So we have to differentiate y is equal to, we have 4x minus 5 to power 3. 4x minus 5 to power 3. Immediately you see this thing, you need to know that, oh, this one we need to use chain rule. There's nothing that we can do. We just have to go and use the chain rule. So solution, we repeat the question. Y is equal to 4x minus 5 to the exponent 3. 4x minus 5 to exponent 3. Now what we are going to do is that, have you seen the function 4x minus 5? We'll represent it with another function or another alphabet. So that is y will now be a function of another function. A function of another function. So the whole of this thing here, 4x minus 5, let it to be u. So we have what? Let u be equal to, let me write the u word. Let u be equal to 4x minus 5. That is it. So now our function, when we put the u here, this is how it will be looking like. Y is equal to, the whole of this is now u. So we have u to which exponent? Exponent 3. Are you following? Are you following? Good. Let's move on. Now what are we going to do now? We are going to differentiate. Differentiate u with respect to s. And also we are going to differentiate y with respect to what? U. So let's differentiate this. So we have du over dx. Giving us, when you differentiate, you have 4 here. This one will blue. So I will differentiate this y. When you differentiate the y with respect to u, we have what? Dy du will be equal to, you drop down the 3. We have 3 u minus 1. You subtract 1 from the part, which we have 2. Are you seeing the point now? Are you seeing what we are getting? Now, our dy over dx will be equal to, we multiply the 2, which is what? Bring dy over dx, multiply by, let me use dots. The dot signifies multiplication. Then we bring du over dy. This is what will happen. You will see we have dy here. So this and this. Sorry, let me see. We have what? Du over dx. Yeah, this is du over dx, and this is dy. Let me state it well. Du over dx, and we have dy over du. Yeah, dy over du. Let me write there. Dy over du. So this is what will happen. This du here, which we are having du over dx, then we have dy over du. What will happen is that, have you seen du here, and have you also seen du here? When this and this cancel, we will still get dy over dx as we have here. So we'll move forward by substituting. What do we have for du over dx? Du over dx, we have 4. Multiply by, what do we have for dy over du? We have 3u squared. 3u squared. 3u squared. So what do we do? Dy over dx, 4 over and multiply the 3. What do we have? We have 12u squared. Now we know that when you differentiate this, this is what we are going to get. But in the original formula or original question given to us, we don't have u in it. We have a function. And we let that function, which is 4x minus 5, to be equal to u. So when you finish solving the question, you don't leave it this way because you are going to lose mark. All you are going to do is that the u here we have, the u that we have here, you are going to bring it back the former or the how it used to be. So we bring it back. So our dy 12. What is u? U is here, which is 4x minus 5 exponent 2. Are we getting the point? You see how it is? It is very easy. When we take the second question also, we'll solve it. After solving, then you will be okay with this. Let's move straight to the second question. For the second question, we have our y is equal to root of 3x plus 2. Root of 3x plus 2. So we repeat the question again. Y is equal to what? Root of 3x plus 2. So what we do is that what? Have you seen this is a square root sign? So we write it properly so that it can fit in. So 3x plus 2 all to the power 1 on 2. Are you getting the point? So this is it. So what do? When we reach this place, we let u to be what? A function. So we let y to be a function of u. So let u be equal to 3x plus 2. Then our function now will be looking like y is equal to u exponent what? Half. Now we'll differentiate u with respect to x. So du over dx is equal to what? Nothing but 3. Then dy over du will be equal to, when you differentiate this, what are we going to get? When you drop down, you have 1 over 2u. Then you subtract 1 from half, you are getting negative 1 on 2. That is what you are going to get. Then our dy over dx will now be equal to du over dx multiplying dy over du. This and this will blow, so we'll still have the same thing. So dy over dx will be equal to, what's du over dx? Du over dx is equal to 3. Multiplying this, which is 1 over 2u, negative 1 on 2. So what do we have? We have 3. When you multiply, you have 3 over 2u exponent 1 on 2, which is dy over dx. So dy over dx is equal to what? Is equal to what? This is what we bring the u back, the former u back, which is the function or the main function. So 3 over 2 was our u. Our u is equal to 3x plus 2 to the exponent 1 on 2. Now, when it is in this form, it can still be written, we can still polish it up nicely. It can be polished up. So y over dx is equal to, we have 3 as the numerator. 3 all over 2 root of what? 3x plus 2. This is the final solution. That is the final answer for this question. That's the final answer for this particular question. We'll still take 2 more questions. After that, we'll call it a day. Okay, so let's take this question, which is what? Y is equal to square root of what? X squared plus 1. So y is equal to what? Square root of what? X squared plus 1. We write it so that it will fit in. So our y is equal to x squared plus 1 all over half. What do? We let y to be equal to u, which is another function. So let u be equal to what? X squared plus 1. So our y now will be looking at what? In place of the x squared plus 1, we'll put a u. So u exponent half. Exponent half. So now we differentiate u with respect to x. So du over dx is equal to 2x. Then dy over du is equal to 1 over 2. We drop down 1 over 2 u exponent 1, negative 1 over 2. Then with that, our dy over dx will be equal to du over dx multiplying the y over the u. So we continue. The y over dx. The u over dx is equal to 2x. Then multiplying this, which is 1 over 2 u negative 1 on 2. So we continue from here. So the y over dx will be equal to, this will give us, this is 2x, so we'll have 2x all over 2, this 2x all over 2 u negative 1 on 2. And you can see that this and this can cancel. So this and this will go. So the y over dx is equal to x, the u. The u, we know that our u is x squared plus 1 negative 1 over 2. We'll polish it up. Our dy over dx will be equal to, dy over dx will be equal to, what do we have here? We'll have x all over root of, we can even have root of, or x all over x squared plus 1 over 2. We can polish it up and still write y, dy over dx is equal to x all over root of x squared plus 1. Root of x squared plus 1. Good. Kindly follow me. Let's solve the last question. Then we'll call it a day. This is the last question, and we'll call it a day. So for our last question, we have y is equal to 5 all over 1 minus x squared or cube. This is what we have. This is what we have. How do we solve it? We write it, we rewrite it. When you look at this, somebody will say that we can solve it with what? Quotient rule. Yes, you can quickly use quotient rule also to solve it. It will give you the same answer. You can use chain rule to solve it. It will still give you the same answer. Sometimes you can use product rule to solve it. It will still give you the same answer. So with this particular question, we're going to blend a whole lot of things. We're blending a whole lot of things to solve it. When you look at this thing critically, this is our u, and this is our what? Our v, u and v. So we'll use quotient rule as far as this is concerned to solve the question. We can use quotient, you can use any other. So our y is equal to 5 all over 1 minus x squared cubed. So we let our u be equal to 5, our v to be equal to 1 minus x squared cubed. So we now differentiate du over dx, but this is a constant, so it will be 0. It won't be anything, it will be 0. And this is what? dv over dx. How do we do it? You go through this process. You can go through this process to get the answer. So that one will be what? A side work. It will just be a side work. Are we getting the point? So when we go through, let's go through that process to get this. And after that, I will teach you a simple way of doing it. So you hold on. This will give us what? This is our v. Our v is equal to what? 1 minus x squared to the third power. So we let u be equal to, this. So u is equal to now, is equal to 1 minus x squared. So our v now is equal to, u to the third power exponent 3. What do we do? So we differentiate u. So du over dx will now be giving us negative 2x. Then dv over du will be giving us 3u squared. I believe you are following. believe they are following. So dv over dx will now be equal to du over dx multiplying dv over du. So this and this will cancel, so we'll move back. So du over dx is this, negative 2x. Multiplying dv over du. dv over du is what? 3u squared. You do the computation very well, you see you have negative 6x u squared. Have you got to the point? So when you continue, you have negative 6x, our dv over du. Sorry, dv over dx. So dv over dx is equal to, what's the function? The function is what? 1 minus x squared exponent 2. This will now be the derivative of, when you differentiate this, when you differentiate this is what you are going to get. So in this, at this place we put this there. So we have negative 6x 1 minus x squared all squared. So that is just a side word. So you cancel with that, you can cancel because we need the space to work with. So what do we have now? So our dy, so our dy over dx will take the v, dy is now equal to v du over dx minus u dv over dx all over v squared. Now what is v? V is this, 1 minus x squared to the power of 3. What is du? Du is 0. Minus, what is u? U is 5. What is dv? dv is negative 6x 1 minus x squared exponent 2 all over v squared. What is v squared? V squared is 1 minus x squared cubed. So what do you think will happen? This will blow. Everything here. So this will be, let me put the thing over. 1 minus v is 1 minus x squared exponent 3 all squared. All squared. So what will happen? This and this will go, because 0 multiplying it will go. Then we have negative 5 and negative 6. This will give us, let me open the bracket first now. This is negative. So this and this will give us negative 30x 1 minus x squared bracket squared. I believe you are getting it. 30x bracket open 1 minus x squared all squared all over. This will give us 1 minus x squared. This and this will multiply, giving us what? 6 indices. So this will give us a positive 30. Positive 30x. Then we have 1 minus x to the x squared to the second power. Then this will be our dy over what? Dx. This will be 1 minus x squared to the 6th power. So you can see that this and this, they are common. So we can still reduce it. This will give us 30x. Then we have what? Because this will cancel, we have 4 here. So we have 1 minus x squared to the 4th power. So finally this is what we have. Finally we have 30s minus 1, 30s all over 1 minus x squared bracket close to the 4th power. I believe you have enjoyed the lesson. Let me give you one bonus of how you can see the question, then you solve it quickly. You solve it quickly without going through this problem. So the first first one that we have solved, let me teach you quickly. Let me clean this one. The first one that we have solved, you compare your answers, then you look at it. So this is the first question that we've solved. So let me clean it. Or this one, no, that's not the first question. So all the questions that we have solved, keep the answer. We'll use a simple method of solving it. So first one we have y is equal to 4x minus 5 exponent 3. 4x minus 5 exponent 3. So what you have to do now is that dy dx is equal to drop this part, drop it. You know that the bracket is having 1 in front of it, but it is not written. So drop the 3. The 3 should come and multiply the invisible one here, which is the same 3. So open the bracket. Now differentiate what is here. Differentiate what is here. What do we have here? Differentiate what is here. When you differentiate, you get 4. You have 4. This one will give you 4, this one will blue. Then repeat the bracket. 4x minus 5. Now subtract 1 from the exponent. We subtract 1 from the 3, you have 2. I'll get to the point. So our dy over dx will be nothing but this will go and multiply this. We have 12. Then we have this 4x and 5. 4x minus 5 squared. Check the first one that we saw. That is it not the answer we've gotten? That is for the first question. The second question, we have y is equal to root of 3x plus 2. What do we do? I said we should polish it up. So our y is equal to 3x plus 2, 1 on 2. 1 on 2. So our y is equal to, now let's differentiate. Our dy over dx, drop the exponent, let it multiply the 1 here. So we have 1 over 2. You open bracket. Differentiate what is here. When you differentiate, you have 3. Then repeat what is here. 3x plus 2. Subtract 1 from the exponent, you have negative 1 over 2. What do we have? This will give us 3 over 2. Then we have what? We have 3x plus 2. Exponent 1 on 2. Then what are we going to get? What we'll be having is that we'll have 3 all over 2, 3x plus 2, 1 over 2. When you check further, you have 3 over 2, then we have 3x plus 2 exponent, square roots. So 2 square roots 3x plus 2. You have it for the second question. So that is another way of doing it. But it depends on the question. The third one we look at y is equal to what? Root of what? X squared plus 1. What do we do? Polish it up. Y is equal to x squared plus 1 half. So what do we do? Drop dy dx. You drop the power 1 over 2. Differentiate what is here. You have 2x. Repeat what is here. X squared plus 1. Subtract 1. You have negative 1 over 2. Then what do we have? Multiply. You know this and this will cancel. So we have x. X squared plus 1. Negative 1 over 2. So when you polish it up, you have x all over x squared plus 1 half. Then finally you have x all over x squared plus 1. Then we have root of that. Then finally we have, I hope I can clean this area. So finally we have y is equal to 5 1 minus x squared cubed. So we rewrite it. Y is equal to 5 1 minus x squared exponent negative 3. With this we are going to go. So our y will now be dy over dx now be equal to this will come and multiply this. What do we have? We have negative negative 15. You differentiate this thing, this one will blow, you have negative 2x. You maintain, you repeat what we have, x squared, subtract 1 from this, you have negative 4. So what do we do now? This will go and multiply. It will produce positive 30. So the y over the x is giving us positive 30x all over 30x. Then we have 1 minus x squared is equal to 4. Then finally, we'll be having 30x all over 1 minus x squared to the 4th power. I believe this video has helped you so much. What I inquire from you to do is to follow, send the video across, let it go to the breadth and length of this country, everywhere, or the length and breadth of this world. Like, share, follow for more mathematical content. Bye bye for now.